Hello everybody, my name is Martin Monperrus. I come from KTH in Sweden. KTH is the Royal Institute of Technology, where I am a professor of software technology there. And originally I'm from France. I got a PhD in the University of Rennes, which is in the western part of France. I also lived in Montreal, in Darmstadt, not really far away from here, and also in Lille, in the northern part of France, where actually Repairnator was invented. So today I'm at KTH. What am I doing as a professor at KTH? So we do three things. So first we train people. So we train students. So for instance, I have a course on DevOps for KTH students. And also, very importantly, we train PhD students. So they spend 4 or 5 years in the lab and they learn how to do research, how to do high-impact research, and this is and then this would last for them for their whole career. So we produce people first. As academic researchers, we also produce papers. So we love to read and to write papers and to do the technology of tomorrow. And so, for instance, today we'll be talking about Repairnator, which was first presented as a research paper. But since we're doing research in software technology, which is applied and which is software, we can actually easily transfer our prototypes from the lab to industry through a process of maturation, of improvement, and this is something which is very, very important to me. So this is why in my group we do some of our prototypes, the best ones, go slowly through this transfer pipeline from really a research idea at the beginning to something that is usable in your company today. So for instance, this is the case of Spoon. Here, Spoon, it's a library for analyzing and transforming Java source code, so a library for metaprogramming. And it's very stable. You can use it today, and many people do use it for doing many different things. And today I'm here to talk not about Spoon, but about the second one here, which is Eclipse Repairnator. So it's a very new Eclipse project. So we started it in the lab like 3 or 4 years ago, actually more. And we joined Eclipse this year in July. And we joined it exactly for this, because we want to facilitate this transfer from what happens in a research lab to how it can be used in a company. And this move to Eclipse is exactly in this direction, so that we have a common playground where companies, universities can share and work together. So Repairnator, so you find like relation to a Hollywood movie, and the first part is this verb repair. It's about automatic repair, automatic bug fixing. What is automatic bug fixing? So automatic bug fixing is the idea that you can have a system which takes bugs as input and which produces patches as output in a fully automated way. This is the idea of automatic bug fixing. So basically, today bug fixing is done by human developers, by you and me. And tomorrow, some of those bugs will be fixed by robots, by automatic bug fixing robots. And Repairnator is one of the very first. So this idea comes from a paper at the end of the years 2000, GenProg, a generic method for automatic software repair by colleagues from University of Virginia and New Mexico. And so it's really a major paper in the field. Why? Because there are very few papers which invent a new research area. And this is what they've done. So basically they settled a new problem, a very interesting one, which is, okay, we have a piece of software written in an arbitrary programming language, C, Java, Python, with a test suite, which is today many of us have. We have a test suite and potentially a strong test suite for specifying the expected behavior. This is what we have. And sometimes we have a bug, and how this bug can be seen, it's because one test fails. So this is a bug. We have a problem. And in this test, we have an oracle, you know, we have an assertion with this expected value, which is what should be the actual behavior. Okay, so it's good. So then basically the story is simply that I have a failing test, and I have to find a patch which makes this failing test pass. And since it's a unit test, say a JUnit test, for instance, you can run this failing test as many times as you need to try out whether a new patch is good, or maybe to do some dynamic analysis because you want to reason about the behavior. So we have this failing test, and then we have this loop: try something, run again the failing test. Try something, run again the failing test. And at some point, if your tool is able to find a patch, you would have a green test instead of a red test. That's good. Now we also don't want to have any regression. So then the problem becomes, I have a piece of software with, let's say, 1,000 tests. One test is failing. So the other 999 are all passing, which is okay. So it's a bug, you know, it's a small problem somewhere. The problem is to find a patch such that the failing test passes and the other tests remain green. They still all pass. Otherwise, what would it be? It would be a regression, basically. So the machine found a patch for this failing test, but it broke something else elsewhere in the code base. So that's simple as this. We have a lot of tests. One is failing. We must find a patch so that this one passes and the other ones remain green. This is a problem statement invented by this group of researchers from America back in the years 2000. And so this has started a new research field. A lot of papers, a lot of tools, and we made progress on the difficulty of the bugs we could handle, because of course you can do like a small example on a toy example or a toy language, but we want this to be real, you know, like real bugs in Java code, for instance. So we keep making progress since then, and Repairnator is one of the milestones. So, because Repairnator, what we wanted to do is to go beyond this technical part of synthesizing patches and to become human competitive. So what does this mean? It means that it's very nice if you can synthesize patches. That's cool. Technically, that's really cool. But if a human can fix a bug in 2 minutes, and the machine needs 2 days to fix the same bugs, it's not really human competitive in that sense. And so in the Repairnator experiment, we wanted like to be the very first to propose a patch which is human competitive with a very clear definition. The patch should come before the human and should be of similar quality. It should be accepted by the developer, you know, as a reasonable patch. This is the 2 dimensions of human competitiveness here. It should come fast and of reasonable quality, comparable to the human patches. So that's it, and now how we could do that. So over the past years, there was this huge explosion of CI. And what happens on CI, so we run tests at every commit. We find again we have those tests. And a good CI system is a system which finds bugs, which has build failures. A good CI is a CI with build failures because it detects bugs. It adds value into the quality assurance process. So now we have this story where we have failing tests happening on CI. And today what the process when CI is failing, the developer is notified, which for instance an email or something in a dashboard on GitHub, that there is one test failing. And what we can do, since we want to be like human competitive, we can create this kind of a race between the human and the machine. When CI fails, the developer is made aware that there is a problem and she tries to fix the issue. And Repairnator tries to run automatic repair systems to find a patch. This is so then this is the problem of automatic repair in the context of CI. We have build failures. So that works well, but we are in a lab, so we don't have access to a production system. We don't have access to a proprietary CI, but we have access to CI of open source. Most open source projects use a CI system called Travis CI. And the information of Travis is publicly available. And Travis even provides an API point to listen to those builds. So now while I'm talking, ding, this is a build on Travis. This is another build on Travis. The third build on Travis. In Java, that's interesting because, if we have a build on Travis which is for Python, we couldn't repair it because our tools only consider Java. Another build. Another build. I'm not taking, it's really thousands of bits per minute. And at some point, one build is failing on Travis CI. What Repairnator does is that it takes this information, the metadata information from Travis CI. It fetches the commit. It does this Maven build, Maven test. Okay, Maven test. So if a build is failing on Travis CI and I do Maven test locally, what should I get? A failure. In theory, the same failure. Okay, so we continue, Maven test. We have the same failure. And then we run these automatic repair tools that we have. And, well, in most of the cases, nothing happens because it's really hard to synthesize a patch. The search space of possible patches is huge. But, there are so many bugs in the world that even if we can repair a few percentage of them, that would be a huge economic saving. Even if we repair only 1% or 0.1% of all bugs in the world in a fully automated manner, this has a huge impact. So in many cases, Repairnator does not find any patch because the problem is too hard, because the search space is too large. In some cases, there is a patch. Now, we want to propose those patches to the developer because we want to prove human competitiveness. And so first we see, okay, there was a build failure, we have a patch, but maybe it has already been fixed by the developer. So we first check whether the patch is still relevant, because if the build is fixed, we don't want to disrupt the developer with an outdated patch, even if it's an automated one. Next, we want to propose, we don't want to disrupt developers with bad patches. And in some cases, the test suite is not strong enough to drive the synthesis of a correct patch. So it's a patch which makes all tests pass, but actually it fails to generalize. It fails to consider all cases, all buggy cases. So we did a quick look on the patch before submitting them to the developer. And then the idea is that, okay, we want to submit them to the developer. We want to Repairnator to create a pull request in a fully automated manner on those open source projects. That's the goal. Now we have a key question. Who should create the pull request? Myself, my student, Repairnator. Well, the thing is that there was a very famous experiment done by the University of Antwerpen, where they created a bot for Stack Overflow, an answering bot, which takes an existing answer from somewhere to answer new questions. They deployed this bot, it was working well, and the persons on Stack Overflow were really pissed off by the fact that the bot could answer their own questions. So they started to downvote. Even if the answer might be correct, downvote. You know, I'm a human, I don't want a bot to answer my own questions. And after 2 weeks, this bot was banned from Stack Overflow. So the researchers at Antwerpen say, okay, this is strange because it's, according to our experiments and our understanding, it gives good results. It gives good answers to those Stack Overflow questions. So maybe there is something else in the big picture than only the quality of the answer. So they took exactly the same bot and they created a fake human identity, which after 2 weeks had a very high reputation. So now in the context of automatic repair, we didn't want our patches to be rejected because they came from a bot. So we wanted to check that we go fast, so that's very easy, and we are of similar quality, the inner quality of the patch. So we did the same thing as our colleagues. We created a fake human identity for Repairnator. So let me introduce my colleague, Luc Ezapé, who is now Repairnator. He's an artificial software developer. He's living somewhere in a data center. It depends, so he can move quite fast. So initially he was in a computer in Lille. Then he lived a little bit in the north of Sweden, where you come from, and in Luleå, in Umeå actually, not Luleå. And no, it moves quite a bit, it depends. But it's an artificial software developer. And initially, Luc didn't have this, also known as Repairnator. It was only Luc Ezapé, like a junior developer, creating pull requests. And he was one of the very first artificial software developers creating pull requests to fix bugs, really with the code change to fix bugs. And at some point, for instance, one of the projects which is on Eclipse is Eclipse Ditto for Internet of Things. And so it's on Travis CI, so there is a lot of builds coming from Travis CI. And one build from Eclipse Ditto is failing. It went through the whole pipeline of Repairnator. Okay, we can reproduce the build. But just here, sometimes it's hard to reproduce a build from Travis CI. So it worked well for Eclipse Ditto, so we can reproduce the build. And we could get a patch, and this patch was before the human patch, and when we looked at the patch, oh, it seems reasonable. So let's propose it to the developer. So Luc Ezapé created a pull request here, you know. Propose a patch for fixing failing tests. And here is a patch. As I told you, automatic repair, it's really hard, so we address a small proportion of bugs, and we fix them with small patches. So we don't write hundreds, so the robot doesn't write 100 lines of code. So this is a typical patch where we have an error, a null pointer exception happening somewhere here, down. And we wrap this statement here by an if statement. And the goal here is to synthesize the condition of this if statement. And here Repairnator identifies that calling this dot is consuming as a proper behavior. So it returns true when it must return true, and it returns false when it must return false. Again, according to the test suite. We run the whole test. Again, we have those 1,000 tests, or even more maybe for Eclipse Ditto, and all tests pass. The patch looks correct. This is a pull request. So we create the pull request on Apache Ditto on May 3rd, 2018. Luc was even like not a very well-behaved developer, so no pull request description. But it's hard to generate a pull request description. And then, so an Eclipse contributor, Thomas. Okay, thank you very much. But by the way, we are here at Eclipse. It's super serious with respect to IP. So please have a look at contributing.md, and we can only accept pull requests which come from users who signed the Eclipse Foundation contributor license agreement. So when my colleague Simon came to me and said, Martin, we have a problem here. So we have a patch, it's been submitted, but we need to sign a license agreement. We started to discuss and said, well, this is a scientific experiment. You know, we want to push the boundaries of what has ever been done. So we want to be the first to have a human competitive patch. So let's sign it. We already have a fake human identity on GitHub, so we can even sign. So we went to the Eclipse website, we signed the license agreement, we signed the commits, and we even force pushed after to re-trigger CI. And then Thomas said, okay, thank you very much. Thanks for going through the Eclipse process and for the fix. And congrats to the first contribution to Eclipse Ditto from outside Bosch. So here it's interesting. So Eclipse Ditto, it's this enterprise open source project where all contributors come from Bosch. And here they saw an external contributor coming out of nowhere to the repo, proposing a patch. And it's indeed very cool, you know. Myself, as an open source developer, I love seeing new contributors, new members in the community. And so Thomas was super happy about that, and we were also super happy because he merged the patch, merge commit. So he merged the patch. So for us, you know, that's a milestone. It means that we show that we can be human competitive. The repair systems today, under certain assumptions, can work on real code, arbitrary code, fast enough, and of similar quality as humans. So like that was our goal, that was our milestone, and this is an example of such a pull request, which shows that we can be human competitive. Okay, so on the way, we didn't know that, so we had to do this license agreement check. Today is still a gray area with respect to intellectual property about who owns the IP of a synthesized patch like this one, where there is some kind of creative activity. So that's an unknown question, but again, for the sake of science, we wanted to do that. So we had at the end, we stopped the experiment after the 10th accepted pull request, showing that okay, we wanted to do so. So we had 10 accepted pull requests, and then later on, we made a full disclosure. So we said to the developers that okay, that was part of a scientific experiment. And we pointed to a post about that, and we thank the developers for their welcoming attitude, you know. So we did this full disclosure for ethical reasons about this experiment. So that was the goal of Repairnator. To hit that, as I told you, part of my job is to write papers. So we wrote papers about that. But now we would like to do this next mile. Now we would like to continue the transfer of this crazy idea, which started in academia somewhere in the year 2007, 2009, and to deploy this for real. There is one similar bot at Facebook. They did so they had a lot of engineering power, so they could also do an automatic repair system for null pointer exception for their Android apps. And now Repairnator is meant to be like the reference open source platform for this. So this is Eclipse Repairnator. It's a repo on GitHub. And so it's meant to be the reference open source platform for automatic program repair. It's meant to be community driven. it's meant to be a very good platform for companies and academics to work together. And when I say a very good platform, it's a repo, but also it's all the IP setup that we all contribute to a common repo. So what do we have today in Repairnator? We have this core Repairnator, which is program repair for Java, for build failures on Travis CI. So of course, many of us, we don't use Travis CI. We may use Jenkins, we may use Circle CI, we may use any other things. That's fine. Again, Repairnator today it's Travis CI and Java, and tomorrow it will be more, because Repairnator will be this common platform. And it's a platform which is really welcoming. The search space of program repair is really hard. The task at hand is really hard, but it's really the future. It's really the future of those bots working together with humans on a piece of code. And there will be many different bots. So there will be repair bots, there will be documentation bots, there will be even bots which would merge pull requests. So maybe you would have a bot which would merge a pull request synthesized by another bot with a different check. And so Repairnator, it's one of these platform to do that. So it's a glimpse into the future of this collaborative software development. So Repairnator, it's welcoming. So for colleagues who in academia who already have repair tools, they can join Repairnator. So you can put new code, you can develop new things in Repairnator. For instance, if you'd like to do automatic repair of, I don't know, SonarQube warnings, that's something you can do in Repairnator. If you want to do automatic repair of check style formatting errors, that's something you can do in Repairnator. So it's meant to be this common platform. It's a nice community. And there are also tasks, good first issues for newcomers who feel excited about these new areas of software development and who would like to join. So if you'd like to join Repairnator, there is an issue for saying hello, which is here. You can come and say hello to Repairnator, and Luc, my colleague Luc will answer you and say hello, welcome to the community. You can also send me an email. We have this repo. We are at Eclipse. We are welcoming, and all together, we can do something really big to make this future of development, of software development, happening. Thank you very much for your attention.
I think there's already bots that merge with one second screen. If that enables in the repository, Repairnator to fix it.
Yeah, so there will be a singularity of bots developing the code base without humans, maybe. But if you have the pointer to a repo doing that, a bot doing that, I would be very interested. Merge and green. Okay, very cool. Do you use it yourself, this bot, or? So flaky test, it's a very interesting question. So first, flaky test with respect to Repairnator, it meant, and it still means today, that in many cases we had a build failure on Travis CI, git clone, Maven test, and it passes locally. What? We want this to work. So we had this problem of not being able to reproduce a failure. We also have the problem that when you do the search of a patch, if when you validate the patch during your search, if one test fails but it's flaky, it doesn't fail because of the patch. There is no causal relation between the failure and the patch, and then you may discard patches which are actually correct. So you don't want to have a flaky test suite for that. And same thing also, if you validate a patch, but actually one test should have failed, that's an issue. So for automatic repair to work well, you need to have a clean, non-flaky test suite. That's very important. The first thing, and now we are also looking at like automatic repair of flakiness themselves. So then we don't try to repair the application code as we do here in this experiment, but we try to repair the test. So how to change a test such that the test suite is not flaky anymore? That's an open question. We are working on this, but we don't have something yet to share. Yes. Yeah. So if you take an arbitrary project on GitHub with a failure, then you lose some project because you can't compile, because basically the POM, the Maven POM, so this is for Maven, the Maven POM does not contain the whole information for some reason, you know. So some don't compile, some, and then the rest, the tests don't run because there is some dependency to an external database, or you know. So basically, it means that there is some additional setup on Travis CI in the Travis YML file, which we don't do. We don't reproduce the same environment. So if you take an arbitrary project on Travis and you do with a build failure and you do Maven test locally, you only get 35% of reproduction of the same failure. 35%. And so that's actually interesting because at the beginning we started Repairnator with a fixed list of the most successful Java projects on GitHub. And after some months we didn't have a single patch. You say, why is that? And it turns out that actually the most successful projects are also the most sophisticated ones. So we started like with the hardest projects ever. And so then we replaced with a dynamic list where we accept basically any build from Travis, and we started to get, you know, smaller projects, and then we started to get some success.